So yesterday, we did that 2.4 lesson. Remember that? Big old monster math lesson where we dug in and understood a little bit, hopefully a little bit more about decimals. And I took a look at some of your papers that you turned in. I took a look at all of them, and I'm going to show you some of the papers right now. And the couple of you that were not here yesterday, you're going to get a little review today of what we did, and hopefully you'll learn some things in going over it. So what I'm going to show you, we're going to go over the first two problems, the first two parts to the problem. It was kind of a three-part thing, wasn't it? It was like writing equations, drawing pictures, and then is 2.4 the same thing as 2 remainder 4? And so we're going to mainly go over the first two parts right now. And I want you to think critically about what people wrote and decide, is this a good representation of how to make 2.4? Either in number sentence form or in picture form. Okay, some of the examples that I'm going to show you are great ones. They're very intelligently done, and some of you might look at it and go, oh, that couldn't be right, but you're the one that's wrong. You just don't get what they're doing because they're really smart and they're doing a great job on it. And then there's others that you might say, oh, yeah, that's the right answer. Oh, that's sure. And then you dig a little bit deeper and you think a little bit more critically and you realize, no, that does not make 2.4. So we're going to start with one that's kind of the remainder idea. And nobody turned in a paper to me that showed me that they understood that you could have 2 remainder 4 and 2.4 is the same thing. Take a look at this circled blue one here. It says 24.0 divided by 10. First of all, ask yourself inside your head, is 24.0 divided by 10 equal to 2.4? Secondly, does it have anything to do with the problem that I gave you? A brain teaser of, does 2.4, or could 2.4 and 2 remainder 4 be the same thing? Talk to your neighbor about what you're thinking about right now. Go. Okay, Zoe, what are you thinking?
I think it doesn't really go with what you're trying to ask us. But
You got to talk way louder than that.
I don't think it goes with what you're trying to ask us to do, but it does. Like, add to
You got some people that are saying they're confused by what you're saying. Can you say that again so maybe have more people understanding you?
it doesn't really go with what you were trying to ask, like the problem that you wanted to do. Like, how would you think of 24 minutes? But it does add to 2.4.
Okay, calling somebody that, I'd like you to go off of what she just said right now. Don't start something new. Think about what she just said, ask her questions, or make comments about what she just said.
Okay. Well, you're saying that, right? She's like doing an equation, and that's what the thing asks us to do. So that's an equation that she did, but I think that she could have done whatever. Yeah, it's an equation.
Okay, Zoe, keep calling on people.
Joey. Yeah. Well, it's a good equation. Well, like Brian said, it's an equation, but like it's not digging in deep enough. I think pretty much anyone can pretty think about.
Okay, does anybody else have something else new that they were thinking about this, something different besides what we've already been talking about? Jose.
Okay, that's the wrong answer, 2.4, because all you have to do is take off the 2 zeros because the power of 10, and it's 1 divided by 24.
Calling somebody.
Ben?
If you divide 24, like divided by, 24.0 divided by 10, it's pretty much just moving the decimal over to the next spot.
So, Ben, do you think that 2.4 is the correct answer to 24 divided by 10, or do you agree with Jose that that's the wrong answer?
I think that's the right answer.
Okay, how many of you think that this is the right answer to this equation? Who thinks it's the wrong answer to the equation? Okay, Tessa, why do you think it's wrong?
Well, it's like Jose said, if you take off the zeros, it's like 1 into 24. But if you take off the 0 and the decimal and not off the 10, it's just 10 into 24, which is 2 remainder 4.
Okay, let me show you something real fast that you're getting confused with. 10, 240. I can take a 0 off of each one and it's the exact same division problem, right? But is this problem 240 divided by 10? It's 24.0. So can I take off this 0 and have it be the same thing as taking off that 0? This 0 is what? 0 what? Tenths. This 0 is 0 ones. Not the same thing. Can't cancel out 0 tens and 0 tenths and 0 wholes, 0 ones. Okay, Raymond.
I think it's the right answer because if you don't have the point 0, then it would just be 2 remainder 4. But since you have the decimal in there, 0.0, you just bring the decimal up, 2.4.
Say what you just said again.
Okay, what you do...
Somebody just got excited. And might have a good reason to be getting excited. Go ahead, Rainey.
Okay, 24 divided by 10 equals 2 remainder 4. But if you do 24.0 divided by 10, it's going to be 2.4, not 2 remainder 4, because it has the 0.0 on there, and you just bring up the decimal point.
Did the light come on for any of you yet? Nobody's commented on this really directly. Nobody's said it straight out what I wanted to hear from you. Talk to your neighbor. What are you thinking right now? Hey, Alex, what are you thinking?
Well, I don't know why she put the decimal 0, 24.0. You can just like read it to 24, and I don't really get much time to talk.
Calling somebody.
Okay, when you do if you take out the decimal.
Here he comes. He's excited. You can erase the green stuff over here. Erase the green stuff and do it over here.
If you go like this and do no decimal,
24 divided by 10.
into 24, you will get a remainder. It'll be 2 remainder 4. If you did it with no decimal, and with the decimal, 24.0, there won't be a remainder because it'll go 2 remainder 4, or then it'll be 2.4. It's all, so that makes those two problems the same thing.
Which means, can you draw a conclusion? Talk to your neighbor. What's the conclusion here? Okay. Malachi, what's the conclusion? Really loud, really loud. Come on.
That they're both the right answer.
Thank you. Call on somebody else.
That a decimal and a remainder can be the same thing.
Call on somebody else.
Okay. Well, this is one of the problems where a remainder and a decimal can be the same thing. This is one of the problems.
Okay, one more. Who else wants to make a comment?
So, okay. Well, just saying that was like Yesenia, Yesenia and Ben sort of figured out the answer. Yesenia figured out the answer to the problem that you said afterwards without even knowing it. So.
Okay, now let's go back to what Izzy said over here, because what she just said is what I want in your head. So she's going to say it to you again, and then you're all going to turn to your neighbor and you're going to repeat what she just said to your neighbor. You're not going to worry about if you're both talking at the same time. I don't care if you're both talking at the same time, that's cool. But I want it coming out of your mouth so that we know it's in your brain. Okay, so tell them again what you said. This is an example, right? Say it again.
This is just one of the problems where a remainder and a decimal can be the same thing.
Is it? Is the remainder and the decimal the same thing? 0.4 and remainder 4. So does that mean that decimals and remainders are the same thing? No. This just happens to work. It's a coincidence, right? It's a coincidence that they are the same thing on this one. How many of you know what a coincidence is? Okay, good. So, Izzy just said something. Do you remember it? Even though I've been talking for the last 15 seconds? Tell your neighbor right now what Izzy just said. Go. Okay, let's move on. Getting it? 2.4 and 2 remainder 4 could be the same thing if it's a coincidence. But that's just a coincidence. Okay, take a look at this one from Carson. I'm going to do a few of these, and I'm just going to tell you what I'm thinking about them so that hopefully it'll kind of sink in, and then I'm going to have you do a few on your own without me. Okay, this is representing 2.4. First of all, I'm telling you right now, it's not a good picture representation of 2.4. We all know that Carson's an amazing math student. Probably has the highest grades in the 4th grade, you know, some of the highest grades for math in our class for the 4th grade. So I'm not making fun of Carson, but I want him and the rest of you to understand this is not a good representation of 2.4. Now he's got this and this colored in, and this one not colored in. That's the first thing I have a problem with. You're going to shade it in, shade everything in that means that. Okay? This is 1, 2, 3, 4 by 1, 2, 3, 4. How many squares are in there?
16.
16. Okay, 16 sixteenths is a whole, and 16 sixteenths is a whole. But then he's got 1, 2, 3, 4 right there. I'm guessing that these 4 are 4 of these. And if he's doing 4 out of how many? 16. 4 out of 16 simplifies, reduces down to what?
1/4.
1/4. Good. Is 1/4 the same thing as 0.4? No. Talk to your neighbor about that right now. Go. Okay. You should have said no because this is equal to 25 out of 100, which is equal to 0.25, which is not the same thing as 0.4. 0.4 is 4/10, not 2500ths. Or this 4 down here at the bottom has nothing to do with 0.4. Nothing at all to do with 0.4. Okay, so this is not, and the rest of his assignment is great. He's one of the kids that figured out that it's not a remainder before we went through that. You can tell he didn't erase it, so he's doing a great job. But I thought that was a good one for us to critique. Now take a look at Hannah's. Again, an excellent math student. Nope, can't see it. Okay, let's bring it down here. 1 plus 2 is 2. We need to pay attention to detail. Math is all about precision and details. You can't have 1 plus 2 is 2. And then she has 2/5 and nothing is 4/10. I see what she's getting at, because 2/5 is equal to 4/10. But why would we add 2/5 and bring it down as 4/10? That doesn't make sense. So what she would probably want to do would be to do 1 and 2/5 plus 1. I think that's what she was trying to do, which comes out to be 2 and 2/5. And then she would show that's equal to 2 and 4/10, which is the opposite way usually how we go, isn't it? We're going up on the numbers instead of down, but she's proving that this comes out the same thing as 2 and 4/10, which is the same thing as 2.4, 2 and 4/10. Reteach that to your neighbor right now. If you do less of the talking most of the time between you and your neighbor, I want you to do the talking this time. Reteach that to your neighbor. Okay, let's move on. Yes?
It could be a time symbol. Just looks like a plus sign.
Oh, okay. I like how you're thinking critically. That could be a time symbol, but we got to make sure, again, with precision in math, that it actually looks like a time symbol, because that looks more like a plus sign to me. But it is a little bit of a crooked plus sign, so maybe it kind of halfway between plus and times, right? And is 1 and 2/5 times 2 equal to 2 and 4/10? Yeah. Do we write multiplication and fraction problems up and down like this? No. So that's a problem there, that you probably want to write it out more like 1 and 2/5 times 2 equals like that. Then it would be much less confusing. Yes?
You can't do that, though.
You can't do that.
You
Yeah,
have to change it into
she's a 4th grader. She's not doing this kind of math yet. But this is equal to what?
7/5
times
2 over 1,
which is equal to
14/5.
5. which is equal to
2 4/5.
is 2 4/5 2.4?
No.
Close, right? 2 4/10 would be the answer, but 2 4/5 doesn't work. Jordan, great critical thinking skill. Okay, one more that I'm going to do on my own, then it's going to be all you. Jackie was very creative here. She used some Roman numerals. Doesn't completely make sense with math, but I like how she was thinking outside the box and getting creative with it. That's awesome. Here, times, minus, plus, minus, plus, minus, plus, minus, one division in there. This is kind of like a lot of the same type of stuff. So what I want to show you about this is I want you to get past just doing the same things. You know, be creative. She got creative on this part, and this part here was kind of like the same things over and over again. All right? Now, I'm showing these to you after spending an hour and 10 minutes on this lesson yesterday and having you walk around and critique each other's work, taking your pencil, you're allowed to change it, you're allowed to look. I asked you to look at each other's papers and to say, oh, that's not quite right. I don't think that is equal to this. And I'm showing you several examples, and I can show you many more that are just like these for just about everybody's here. So did you think critically yesterday? Well, yeah, you did. I mean, thinking critically is not a yes or no answer, right? Thinking critically is like, I was really thinking critically about this, or I was just barely thinking. You see what I'm saying? Or someplace in here in between. How much critical thinking did you do when I asked you to walk around and check out each other's papers? Were you really challenging yourself and making your brain go so that you get smarter? Talk to your neighbor about the answer to that question. Thank you. Now, think overall, I want to score on, not yet, but think about it, on a score on a 1 to 5 scale, 1 being the worst, 5 the best. The entire hour and 10 minutes, you had many opportunities to think critically. You were sitting with a partner working. Were you thinking critically, or was the person saying, oh yeah, 1 and 2 and 2.4, that's the same thing as like 2.04. Oh, okay, let's write that down. And you're not even thinking critically about it. Okay, so you had opportunities right there to think critically. You had opportunities when you were walking around the room. You had opportunities, remember we put the people in different spots and you guys all went to them? And you were supposed to, we had opportunities when Ben and Jolie were up here. Were you thinking critically about what they were saying? Etc., etc. Lots of opportunities. On a scale of 1 to 5, and I'm not going to come out and punch you or anything, don't worry. On a scale of 1 to 5, how much critical thinking were you doing yesterday on this assignment, do you think? Okay, most of you have given yourselves scores in the 3 range. No, you're not too hard on yourself and not too good on yourself. Okay. Now, think real critically on this one. You ready? Talk to your neighbor on that picture right there for 2.4. Ready? Go. Okay, should we hear from Vanessa on this one? Yeah, this is Vanessa's paper. Vanessa, what do you think about this? You think it's a good picture to represent 2.4? Don't say no if the answer is yes, and don't say yes if the answer is no. What do you think? You don't think it is? Why? Don't give up. Come on, I want to hear from you. You're super smart. Why do you think this is not 2.4? What do you think it represents? What decimal would you give to that? Now, I don't want you to have a nervous breakdown on me. Can you give me anything? Can you say any answer to it? No? Okay, call on somebody. Lots of people want to get involved here. Let's get somebody different. Pick somebody that has not participated in this lesson so far. Put your hand down if you've already said something out loud to the whole class. Solely, put your hand down if you've already said something to the whole class.
Well, I don't think it is because it's 2 holes and then 1 4. So
So that'd be 2.25.
Thumbs? Okay, that is correct. That is 2.25, so that's not 2.4. Those are not equal to each other. Okay, take a look at this one right here. Here's Mark's. Okay, talk to your neighbor. Is that 2.4? Go.
Yeah, you can be double it. Yeah,
Thumbs. Okay, let me do this. I can't tell too easily. Raise your hand if you agree that this is a 2.4. Raise your hand if you think it's not 2.4. And?
Well, he didn't do the problem right. You weren't allowed to have a single number in your picture. That's what.
No, this is not a picture one.
Oh.
Mark, defend yourself.
Well, I doubled it. I just kept on doubling it. See? I doubled it from 2 4/10 to 2 8/20. Double that to 2 16/40, and then double that.
I know what you did.
So why are you still saying no?
Because you put no in your picture.
That is a good representation of 2.4. Take a look at this one right there. Talk to your neighbor. Is that 2.4? Go. Now let's take a vote again. Raise your hand if you agree that that is 2.4. Raise your hand if you think it's not 2.4. Okay, stand up and go find somebody with your thumb that disagrees with you. You can have two thumbs. Two thumbs
One number half. Yeah. One number half. Yeah, but look.
I heard some confusion. So Sam, yes or no on that decimal point right there?
No, it's only 0.8 times 3.
0.8 times 3, okay? Show me on your thumbs how you're feeling about this one right now. Let's do it again. Raise your hand if you think that that does come out to be 2.4. Raise your hand if you think it does not come out to be 2.4. Okay, Jolie, tell us why.
Okay, well, like, you see the time symbol, and there's like a dot right next to it.
We just asked Sam if that's a decimal point. He said no. Okay, so raise your hand if you think it's not 2.4. Victor, why not?
Because that's a decimal right there. So 8 times 3 equals 24 hundredths, not 2.4.
So you think the answer is 0.24?
Yes.
So you think the answer is 0.24?
Yes.
Okay, raise your hand if you disagree with Victor and he'll call on you. You can tell him why you think he's wrong.
Ben!
Well, point, like.
No, let's call on somebody different. Let's get some different people involved. Ben's already been up to the board.
Jose.
Okay, it's yes, because it's 0.8 times 3. 8 times 3 is 24, and there's only one number after the decimal. So you move the decimal point one spot, so it's 2.4.
Okay, go Victor.
What?
Go. Yeah, explain it.
No, because the decimal point right there makes this number automatically go, any number that gets multiplied go behind the decimal point, right there.
Okay, you can have a seat. We're going to move on. But Victor, you're a little confused, and other people on how to multiply decimals. There's one number past the decimal point here. There are no numbers past the decimal point here. So that means we need one number past the decimal point in our answer, which makes it 2.4. 0.8 times 3 is, and think about it. Think about what 0.8 plus 0.8 is. 8 tenths and 8 tenths is what? 16 tenths. You guys should know how to add fractions with common denominators. And then we just have to add one more 8 tenth. Because this is 8 tenths times 3. Most of you are watching. So we have 8 tenths added to this 16 tenths that we already have, which is what?
24 tenths.
24 tenths. 24 tenths. Okay, 10 goes into 24 how many times?
2.
Remainder?
4.
Or 2.4. We just found that out, right? 24 divided by 10. So 2.4 is the answer. You can prove that right there by doing it as a fraction problem. Okay, last one, then we're done. Whoa. Oh, then we'll be satisfied for this lesson. That will be out of time. Okay. Thank you for holding me accountable to that. I want you to talk about these two problems, and I also want to see if you can make a connection between these two problems. Talk about whether you think they're right, and talk about if there's a connection between the two problems. Talk to your neighbor. Go. Hey, thumbs? Oh, we should do them individually. Sorry, I forgot there's two problems up here. Okay, thumb on the first one. That is correct representation. Okay, Tessa, call on somebody. Raise your hand if you'd like to speak. Let's try to get somebody new involved that has not been speaking out to the whole class here. Maybe some of you could raise your hand that never raised your hand too. That would be really nice.
Hannah?
Well, on number 4, if you would multiply those, you would get 4 hundredths, so that would be 2.04.
Thumbs on your response to that? Anybody want to answer Hannah?
Raining?
Oh, well, I've already.
Go ahead.
Oh, well, anyways, 2 and 1/25. How does that go with 2.4? How does 2.4?
Well, Hannah just explained her thinking on it. Do you disagree with her thinking?
No.
Okay, so then it sounds like it's unanimous that we agree that this is equal to what?
2.04.
Right. Talk about the second one, right? Oh, let me see on your thumbs first of all. How do you feel about the second one? Anybody find a connection? Okay, somebody that has not gotten a turn to speak out to the class. I would love to see some of you guys that have sat there with your hands down on the ground the whole time and haven't raised your hand. Raise your hand right now. Get involved in this discussion. Andrea.
Well, the 6 goes into 12 2 times, but the 6 doesn't go into 2. So they didn't put a 0.
Thumbs? Okay, anybody want to respond to Andrea? Stacy?
I totally agree with her because if you try to do 6 goes into 24, especially when you put the 2 after when you put, because 6 goes into 12 2 times. That's right. Drop down the 2. 6 can't go into 2, so you have to put a 0 above it, and then you have to bring down the 4. Then it would work. Then you would get it. Then you would get 2 points.
You lost some people there. That's okay.
Oh,
we're going to run out of time, but what is the connection between these two problems? Tessa, what's the connection? Calling somebody to help you out. What's the connection?
Ruby?
Well, the answer for both of them is 2.04.
Does it matter where we put numbers after the decimal point? If we put 2.4 and 2.04 or 2.004, is that pretty much the same thing?
No.
Could we put 2.40 and 2.4000 and 2.4000? And is that pretty much the same thing? Because the zeros have to be sandwiched in between the decimal point and the other number to mean something. Let me show that to you. Let's take a different number, 6.3. If I sandwich a 0 in here, it means something. It changes the value of that number. Keep looking. If I put a 0 out here, it's not sandwiched in between the number and the decimal point. This 0 is meaningless. Can I put a 0 out here and have it be meaningless?
Yes.
Yeah, that 0 out there doesn't mean anything either. But what if I put a 0 right there and sandwich it in between the 6 and the decimal point? Now the 6 becomes 60. And that's a completely different number than 0.6. Okay, tell your neighbor before you go back, what's the biggest aha that you had today? What was the biggest, for you, it might have something to do with the way you treated yesterday's lesson. You might not have learned anything about math that much today. But maybe you did learn something about math. What was your biggest aha moment today that your brain went, I get this? Okay, tell your neighbor right now, go.